Hi everyone, welcome to the fifth and final BREEDPLAN Basics webinar. So tonight's webinar is on understanding selection indexes. So my name's Catriona and I'm a technical officer with SBTS and I'll be facilitating tonight's webinar, and Alex McDonald will be presenting tonight's webinar. So before we get started, we've just got a couple of housekeeping things to run through. So on your screen, you've got a red arrow up here, and if your question box disappears at any time during the webinar tonight, you can click on that red arrow up here to get it back. Alex will be stopping for questions a couple of times throughout the webinar tonight, so if you've got a question, type your question into the box here in the questions pane and then send, and then we'll answer those questions through the webinar. If you're having audio problems, you can call in using your telephone by switching your audio from mic and speakers to telephone and then dial in using the number provided. So you'll have a dial-in number, an access code and an audio pin. So with that, I'm going to hand over to Alex to start tonight's webinar.
Okay, good evening everyone. My name's Alex McDonald, and as Catriona said, I'm going to present this particular session on understanding selection indexes. So those of you who have been with us all the way through will know that we're now up to our fifth webinar, and this one is, as I just said, understanding selection indexes. So what we will outline in this presentation is, first of all, what is a selection index, how to use selection indexes, and responses to using selection indexes. So in the previous sessions, you would be aware that we've now got something like 18 different EBVs that you can use to make selection decisions. The question becomes, just how much emphasis do you put on each individual index? And so what selection indexes are about is trying to make that much easier for you. As we've suggested there, it's a simple solution to a complex problem. They can take out the hard work of knowing just how much emphasis to give different traits. We can do it intuitively, but I would suggest that doing it intuitively is probably not going to do as good a job as using a formal index when selecting bulls to improve the profitability of your herd. So indexes are actually an EBV for profit for a specific production market scenario. As I said, it's an overall EBV of an animal's genetic value for that particular market and breeding system, and the important thing is that it's expressed in dollars, which is all about profitability. So what an index does is it puts the correct weightings on each trait to allow maximum overall genetic progress. And the weightings that it puts on each trait are going to be influenced by the end market, and it's also going to be influenced by the interaction between traits. So for example, if your market is paying a high premium for extra weight, then the index will take account of the fact that extra weight gain is not without some correlated effects such as increasing birth weight. So that is all taken into account in the index. So we have each breed has a number of indexes which may range from 1 In this example, there is at the moment just the one Wagyu index, which is a full blood terminal index, whereas breeds such as Angus and Hereford have 4 indexes, all targeting different markets. And in the case of Limousin, for example, there are 4 different indexes, some of which are what we call terminal indexes, and some are one of which is self-replacing. And I'll explain that a little more as we go through. Each breed tends to have used different terminology for what in many cases are very similar indexes. Hereford, for example, uses a supermarket index. Shorthorn uses a domestic maternal, probably very similar in their outcomes. Santa Gertrudis uses domestic, Simmental domestic. Limousin use Vila, which is also, of course, a domestic index. Now, of course, you don't have to use the specified breed society indexes. You can actually go and design your own index, and to do that you need to go to the Breed Object website, where it will allow you to design your own index. And for example, if you're a commercial breeder who wants to do a bit different to what's currently offered by the breed society or the breed that you buy your bulls from, you can again go and design your own index, which allows you to make decisions on which bulls you buy. So, how do we use indexes in practice? The first decision you need to make is to decide which is the index most relevant to your production system. In the case of a commercial breeder, are you supplying domestic market? Are you supplying an export market? Or are you sort of trying to hit all bases? And if I just go back, you'll see that the Angus breed has actually introduced an overall index called the Angus Breeding Index, which is designed to allow you to target a range of markets. Angus is the only breed that's actually done that at this stage, but that's an advantage of trying to meet a range of markets, or allows you as a commercial breeder to try and reach a range of markets. So having selected the index most relevant to you, you would then, if you had a sale catalogue available or you were looking for sires, you would go onto the website for that particular breed or that particular sale, and you could rank all of the animals in that sale catalogue or all the sires in that breed for the particular index that suits your production system. We also suggest that having ranked animals on their index, preferred index, it's always worth having a look at the individual EBVs of the animals with those particular indexes. And I'll show you an example later on that you can get quite different ranges of EBVs for 2 animals or more animals that actually have the same index, and I'll demonstrate that to you later. And then having done all that, you compare the expected difference in progeny profitability, and that's what an index does. It's predicting the difference in the profitability of the progeny of that particular animal per cow joint mated. Now I'm going to use an example of Limousin because it's one that I'm familiar with, but I could be using the indexes for any individual breed. The Limousin breed has 3 terminal indexes. It's predominantly a terminal sire, meaning that all progeny is slaughtered, so no daughters are kept for breeding. So Limousin has, for example, a domestic terminal index, a heavy steer terminal index, a Vila terminal index, and then they have a self-replacing index for herds that are going to keep the female progeny and breed from them. So if I were to go onto the Limousin website, into the EBV search area, it allows me to rank, in this case, Limousin sires for the index that I'm interested in, which in this case, as you'll see, I've highlighted the self-replacing index, and you'll see that it ranks sires from the highest to the lowest. That's a fairly busy slide, but what you need to be looking is a column which says self-replacing index. Now, you can also on that website look up or on that particular search down the bottom, you can find the percentile tables for all the EBVs, and that percentile table will also give you the percentiles for all of the indexes. And this is the Limousin example again, where the value is given for animals that are the cutoffs for being in the top 1%, top 5%, top 10%, etc. So if a Limousin sire had a Vila terminal index, let's say of 52, you would see that that would put that particular sire in the top 1% for the Limousin breed for that particular index. If it had a domestic terminal index of 35, if you look up that percentile table, you would see that that puts that particular sire, or for that matter dam, in the top 40% for the breed. So at 35 it's in the top 40%, at 45 it's going to be in the top 15%, and so on. So that percentile table just shows you not in addition to what the index is, just where it fits within the particular breed for that index. Now, as I mentioned, it's always a good idea to have a look at the individual EBVs, and in this case we've got 4 sires with exactly the same terminal index, exactly the same self-replacing index, but you will see that first of all there is quite a range of birth weight EBVs. Bulls with the same index range from 1.8 to 4.8 for birth weight. So if you were in an environment where calving difficulty is a real issue, then within those animals you may well choose the Bull D because he's got a lower birth weight in EBV than Bull A, or somewhere in between. You might be happy with all of Bull B, Bull C and Bull D, but you would shy away from Bull A because of his birth weight. You can see there's a significant variation in mature cow weight. Bull A will produce daughters with significantly heavier mature cow weight than Bull D. So you may prefer, if you're concerned about keeping your mature cow weights down a bit, you may well again select Bull D. Milk, same story, quite a range. The EBVs for milk within the 4 sires with the same index range from 6 to 16. If you're in a tough environment where really heavy milking cows have a bit of trouble getting back in calf, you may well opt for Bull A rather than Bull B, based on the high milking production or high milking EBV of Bull B. Of course, if you are keeping females and you really want to maximise milk, then that would make you decide to go the other way. You would pick the sire that the Bull B with the highest milk. Now, the Limousin breed has a docility EBV along with several other breeds. The docility EBV is not included in the index, so it is well worth just checking docility EBV if that's a concern to you, and you can see that there's a huge range in these four sires for docility, with the lowest at +12, which is well below breed average for the Limousin breed, to +71, which is right up near the top for the breed. So if docility was a concern to you, then you would certainly go for Bull B over Bull A, even though the indexes were the same. But having said that, you could probably happily use Bull C and Bull D. It's the Bull A that you would be wary of because he's well below average for the breed. So how do we interpret selection indexes? How do we use them? What do they mean? I've just used an example here of a bull called Fred, who's got a self-replacing index of 78, compared to a bull called Bob, who's got a self-replacing index of $20. So just as for EBVs, we expect half the difference to be expressed in the progeny. So in this case, the difference between these two sires is $58. Divide by 2, it's $29 per cow mated. Now, if a bull was to join 200 cows over his breeding life, that equates to quite a lot of money. 200 calves worth $29 more each is about $5,800. Not about, it is exactly $5,800 between the progeny, the value of the progeny of 200 progeny or 200 cows mated between Fred and Bob. Now, normally you won't see that bigger range in indexes, but there is that bigger range available, and it can be worth a lot of money. So I'm just going to throw to Catriona to see if there are any questions.
No, there's no questions yet, Alex.
Okay, that means that I've either totally confused everyone or you've actually understood everything I've said. So don't be frightened to ask questions. So I'm going to move on to the next.
Alex, I've just had a question come through now.
Yep.
So the question is, how are the various indexes calculated from the base EBVs?
Indexes are really not concerned with the base EBVs. Just as EBVs are describing differences between animals, indexes are also describing differences between those animals. An EBV explains the difference in the measurement of the EBV, which might be growth in kilos or scrotal size in centimetres or eye muscle area in square centimetres. An index does it in dollars. So it's really not relevant where the base is. The key issue is the difference between the individual animals.
Thanks, Alex. That's the only question at the moment. And we've just had another question come through. So the index formation is specific and proprietary to a breed.
Absolutely correct. Just as EBVs can only be compared within breed, indexes also can only be compared within breed. And even more importantly, the assumptions in a self-replacing domestic index for one breed might be somewhat different to the assumptions in the domestic self-replacing index for another breed. So the person who asked the questions is exactly right. They can only be compared within breed.
Thanks, Alex. There's no more questions at this stage.
Okay, thanks for those questions. So let's move on. This is a little, if we considered the first section as indexes 101, in other words, the basics of indexes, this is indexes 102, which is showing you a bit of the background information to the outcomes of deciding on an index, and also what it's likely to do if you select your herd using that particular index. Now, what I haven't said is that in setting up an index, the Breed Society Technical Officer or the SBTS Technical Officer, in association with some breeders for that breed, answer a number of questions as to the current situation with the breed in terms of, you know, what is the current calving difficulty level in heifers in your breed, what's the value of an extra kilo of carcass weight, what's the value of an extra marbling score, and so on. So that's to design the index, you need to answer a whole range of questions, and then what we call a black box takes into account the answers to all those questions, and it comes up with the index. So let's have a look at a couple of examples. Again, I'm going to use Limousin because I'm comfortable, I understand their index as well, but I could be using any breed. So this is the Limousin self-replacing index, meaning, as I've said before, any self-replacing index means that female progeny are kept for breeding as opposed to a terminal index. Now, most of the indexes that I showed you earlier on for all the breeds are in fact self-replacing indexes. It's really only the European breeds who produce terminal indexes. So this is an example which would be typical of the indexes for most breeds, most of the indexes for most breeds. So this index in the Limousin breed estimates the genetic difference between animals in net profitability per cow joined for an example self-replacing commercial purebred Limousin herd targeting the production of heavy steers. So we've defined, and this is all comes out of the questionnaire, the steers are being finished on grass or a short-fed grain program and are marketed at 580 kilograms live weight, which is equivalent to 320 kilograms carcass weight at 24 months of age. And as I've said, because it's self-replacing, the daughters are retained for breeding, so maternal traits are important. Now we have three graphs. We call them the blue graph, the red graph, and the green graph. And these are available again for all indexes for all breeds. So this is what we call the profit drivers, and this is this particular index. And you'll note that profit drivers don't necessarily have EBVs directly describing the actual trait. And a good example of this is that, for example, dressing percentage, there's no EBV for dressing percentage, but dressing percentage does play a role in the profitability of a breeding program, dressing percentage being the ratio of carcass as a proportion of live weight. If you look down a bit further, you'll see that a profit driver is cow weaning rate. We don't have an EBV for cow weaning rate. What we do have are EBVs for female fertility and male fertility, which both impact cow weaning rate. Marbling score, in this case, we do have a direct, well, no, we don't have a direct EBV. We have a direct EBV for intramuscular fat, which is closely related to marble score, except for Wagyus who actually have an EBV for marble score, cow survival rate, and so on. So they're the profit drivers, and they're what are basically the underpinning drivers, if you like, of an index. So what we can then look at is what we call the red graph, and what the red graph shows us is the proportion of, or the weighting that is put on the individual EBVs which are available for that particular breed. And so you'll see all of those traits down the left-hand side have EBVs available. And this shows you that for this particular self-replacing index for Limousin breed, calving ease direct has the most emphasis on it, obviously because calving ease, live calves are very important to profitability. The next most important EBV is 600-day weight, and there is small amount on 400 and 200 because already we've accounted for most of that in the 600-day EBV. P8 fat depth, there is a positive emphasis on P8 fat depth. Remember, we're talking about a lean breed where they're more likely to have not enough fat than too much fat. And retail beef yield has a 9% weighting as well. So you can see there that it gives you a mental picture, or a visual picture of just what the weighting is on each of the EBVs which are being used to calculate this index. What I didn't say there is that birth weight, for example, in this index there is a -3% weighting on birth weight, so it's trying to hold birth weight constant or even decrease it a little bit. Days to calving also has a -2%, and that may be a little bit confusing, but the way the days to calving EBV works is that the more negative it is, then the more favourable it is. So that's why days to calving in this index, the female fertility trait, has a negative weighting. The negative weighting is favourable. So then we have what we call a green graph. So what the green graph shows us is that if you only use sires in the top 10 percentile for that particular index, this one is the Limousin self-replacing index, this is the response we would expect for each trait. Positive being, well, positive means increased plus, and the bottom line is a decrease. So if we look at calving ease direct, if you selected only on this index, you would see an increase expected. This is expected in expressed in what we call standard deviations to make everything relative. You would see significant increase in calving ease direct. You would see an increase in calving ease daughters. You would see a significant decrease in gestation lengths, which is favourable. We do like shorter gestation lengths. Some decrease in birth weight, and at the same time a good increase in 200, 400 and 600 day weights, with some increase in, or a significant increase in mature cow weight as well. Milk will go up, days to calving will go down, which is all positive. Scrotal size goes up, carcass weight goes up, which is because we've got increased growth. Eye muscle area will go up, rib fat will go up a bit, rump fat will go up a bit, retail beef yield will go up, and intramuscular fat will go up. So that's the expected change if we use that index. Now I just want you to look at IMF percent, and I'm just going to go back to the red graph, and if you go to intramuscular fat, in fact if you go back to the blue graph, you'll see we actually had no, in this particular index, there was no pressure at all on marbling score as a profit driver. Now, once the index is calculated, you'll see it is going to try and push intramuscular fat or marbling up a little bit. And interestingly, in the green graph, IMF is going to go up significantly using this index, and it's mainly because the index, the IMF percent, is correlated with rib fat and rump fat. So if you increase those two, you'll tend to get an increase in IMF percent as well. So this green graph is taking into account exactly what the index does and says, well, even though you, for example, mightn't really want mature cow weight to go up, because you're selecting on these growth traits, mature cow weight's going to go up anyway because of its correlation with these growth traits. I hope that's not too confusing, but I'm going to go and give you another example, which is, sorry, before I do that, these are the top 10 sires in the Limousin breed for that self-replacing index. If you went in and sorted for sires on the Limousin website, these are going to be the top 10 sires. Now, of course, you can do that for any breed. So now I'm going to look at a Limousin domestic terminal index, and remembering again that a terminal index means that all progeny are sold, so no females are kept as replacements. So this index estimates the genetic difference between animals in net profitability per cow join for an example commercial crossbred herd using Limousin bulls over British bred females and targeting the domestic market. Steers are either finished on grass or a short-fed program, marketed at 475 kilos, about 260 carcass weight, at 16 months of age, or male and female progeny. So let's go and have a look at blue graphs, red graphs, and green graphs. So these are the profit drivers for this domestic terminal index. And you'll note that there is no influence on what we call the maternal traits. So cow weaning rate's not important because we don't keep any females. Cow survival rate, cow weight, calving ease maternal, and live weight maternal, which is milk or driven by milk, get no emphasis in this index. So the key profit drivers are sale live weight, calving ease direct, so we've got to get live calves and we've got to maximise their growth. Dressing percentage has some influence, has some emphasis. Saleable meat yield has some emphasis, and fat depth, in other words, more fat is going to be favourable, has significant emphasis as well, but no emphasis at all on the maternal traits because we're not keeping any females. So again, this is reflected in the EBV weightings. The relative influence is greatest on 400-day weight, closely followed by calving ease direct. We want to try and push birth weight down. Intramuscular fat has some influence. P8 fat depth is quite important. Retail beef yield is quite important, and eye muscle area is important as well. So this is what we call the green graph, or in other words, the expected response if you were using sires only in the top 10% of the breed for this index. Now you'll note that even though we had no influence on maternal traits such as milk or days to calving or mature cow weight, the reality is that if you select on this index, it is going to change these EBVs. So you can see that selecting on this index is going to increase the growth rate of your herd. It's certainly going to increase carcass weight of your herd. It's going to increase fat a little bit, retail beef yield, and it's going to increase intramuscular fat. And at the same time, it's going to decrease days to calving, female fertility, and gestation length. So while you're not keeping females, this is the impact that selecting on this index would have in your herd. So there again is a list of the top 10 sires for that particular domestic terminal index. Interestingly, there are a few sires that come up in both indexes, but there is a significant change. For example, I'm pretty sure that bull and that bull were not in the top 10 for top 10 for the self-replacing index. So each breed has tip sheets which are available on the web, and I'll show you where to find them in just a moment, but those tip sheets give an explanation of the selection index, just as I've tried to do tonight. They will show you the blue graph, I'll show you the red graph, and then they'll show you the green graph. So to find those tip sheets, you need to go to the BREEDPLAN. Well, one way to find them is to go to the BREEDPLAN website, which you can just Google as BREEDPLAN website. And in that particular front page, you'll see that there is tip sheets there for all the breeds that have a selection index, plus some information, just general information on indexes. As I said, those tip sheets include just what we've been talking about for each breed, for each index. So let me just summarise, and I think we're going to finish a little bit earlier tonight unless there's lots of questions. Selection indexes are breed specific, as pointed out by one of the questioners. Selection indexes are a weighting of different traits, taking into account the economic importance of the trait, but also its interaction with other traits. Animals, as we've demonstrated, can have the same selection index but be very different in their EBV makeup, and that may be important to you. You should always have a look at the individual EBVs. And finally, each selection index being developed for a specific production system and market, end market. So production system basically being self-replacing or terminal, and of course the range of markets that are out there for each breed. And so we do get a difference in ranking for animals for different selection indexes within the same breed. So as I think you would have seen this slide for the last 4 weeks, these are the people to contact if you would like more information about the indexes for your breed. I handle the Limousin, Simmental and Wagyu questions. Catriona handles a whole range of breeds in there, Blonde, Charolais, Devon, Geltfie, Hereford, etc. Paul Williams does the northern breeds, the tropical breeds, and Andrew Byrne handles the questions about the Angus breed. So with that, I will say thank you for tuning in tonight, and I'm going to throw to Catriona to see if there are any questions.
Thanks, Alex. We've got a couple of questions. So the first one is, if direct EBVs are not the only data inputs for a selection index, how does BREEDPLAN get the data to produce the index?
If I'm understanding the question correctly, the system uses the correlation between the EBV, or the trait we can measure, and the economic trait. So, for example, cow weaning rate is obviously affected by the EBV, which is days to calving. So it uses the correlation between the EBV and the economic trait.
Thanks, Alex. We've got another couple of questions. So, once the selection index data weightings are determined, how is the dollar value calculated?
The simple answer is that the black box does that. The underlying assumptions and theory of indexes, or index theory, are all built into the breed object software, which is able to come up with the dollar value. But as I've said, it's driven by what you the breeder or you the breed have told breed object are the current levels of your herd and the current relative value of increasing or decreasing a particular trait. for example, extra marbling or extra growth rate or high yield or etc. So it is quite sophisticated bit of software that comes up with it, but I can assure you it's been designed by people who really understand indexes very well. And I should also comment that, you know, indexes are not unique to the beef industry. The chicken industry and the swine industry, the pork industry have been using indexes for selection for decades. The sheep industry, the dairy industry, all use indexes. So it's an established science-based methodology which comes up with the final index for, or the final dollar value for each index for each breed.
And we've got one final question at this stage, which is, Devons do not appear to have any selection indexes. Should these be developed?
It's really up to the Devon breed to request an index. Indexes work best when you've got a big range of traits, including growth traits and fertility traits and carcass traits. I think Devons have a bit of a limited range of traits, which sort of limits the value of indexes, but they could produce an index.
And that's all the questions we've got at the moment, Alex. So thank you everyone for coming. When we close the webinar, we're going to you'll have a survey pop up. So if you could take a couple of minutes to fill that out, we'd really appreciate that. And as Alex said, if you've got any further questions, please feel free to contact your SBTS or TBTS technical officer. Thanks, everyone.
Thank you and good night.